Okay, hi, hello, my dear students. How are you all? I hope that everybody is fine, and I, Ritika, welcome you all here at Unacademy. Now, as you all know that your term 2 examinations are around the corner, so we are here together at Unacademy to take our preparations to next level and to ace our term 2 examination with Unacademy Plus. Now, what is this Unacademy Plus? I'll be telling you shortly. And what is this 10% off that too? So you will be getting very important informations. So all you need to do is just stay here. Now, I welcome you all to the class. I am Ritika, a chemistry educator on Unacademy. I have completed my engineering in electronics and communication and also been awarded grade A in the Cambridge English EOSL. Enough about me, now talking about our topic for today. So today we are going to basically focus on Mendeleev's periodic table. So students, you might be knowing that we have started the series of periodic table for grade 9. Okay, we have already done Dobonius triads and Newlands Law of octaves, and today we are going to focus on Mendeleev's periodic table. So there are various important things about Mendeleev's periodic table that we are going to discuss in our today's class. Okay, students, you can follow the page Unacademy Champions on Telegram, whose link is provided to you in the description box. Okay, now why to follow this page? Because this page will bring with it all the important updates and all the important information related to Unacademy. That is the information about batches, the information about the live classes, that is the special classes, and the information about the YouTube classes. So this becomes a very important step in your preparation for examination. Just you need to click on a link in the description box and please follow the page. And also, if you like this video, kindly press on thumbs up, subscribe to the page and press the bell icon. And if you press the bell icon, you won't be missing any update. So students, I need a help from you. Let's target 1000 subscribers. So please share this video with your friends, okay, so that they can also take advantage of these lessons. All right. Okay. Now we will be having a quick revision about all our previous learnings, and then we will be moving on to our today's topic, which is primarily Mendeleev's periodic law. Okay, now as I told you, in the year 1800 there were only 31 elements. Okay, so it was not very difficult, I can say, but as the number was increasing, that is in 1865 the elements they were about 63. So, and right now it is 118 almost. Okay, so with increasing numbers, it was very difficult to study the properties of individual elements. So there was a need of a systematic arrangement, of a proper arrangement of elements so that the study could be a bit easier. Okay, now if I talk about the periodic table, we are right now studying modern periodic table, right? But this table didn't come so easily. So there were many trial and error methods that happened. Many scientists tried their best, okay, and then at the last we settled on to what we call as modern periodic table. Now let us see some of the advantages of classification. Why did scientists go into such hard work and why they wanted to arrange the elements into a table. Okay, so first of all, we just wanted to go for classification because we needed to have a systematic study of elements. So first thing is, it was because we needed to study the elements systematically. Next is the classification. It helped to correlate the properties of elements with one another. Okay, so that becomes another major or main property. Okay, and third is, it it helps to define the relationship of elements. Okay, so these were the main reasons why we needed to classify the elements properly, okay, to have a bit easier study, right? Okay. Next, there were certain trials which were made, right? It didn't come so easily, as I told you. So there were many scientists who tried their way best, okay, to give our modern periodic table. Okay, so at the first attempt, it was made by Dobonier. Okay, so he was a German scientist, Johann Wolfgang Dobonier. He identified that some elements which were having kind of similar properties, we could group them into three. Okay, and since this was a group of three, it was referred to as triads. And the elements of a particular triad, they possessed similar kind of chemical and physical properties. Okay, now I'll just give you an example of how did it happen. So for example, he tried to group the elements into three elements each, into a group of three triad each. Okay, so for example, if I take the case of chlorine, bromine and iodine. So what did Dobonier do? He tried to group it. Now, according to Dobonier, he told that if I take out the average of mass of chlorine and iodine, that is the first and the third element, I will be getting the approximate mass of second element. Now, this is what it was told by him. Now, if we go for the mass of chlorine, which is 35.5, the mass of iodine is 127 and the mass of bromine is 80. Now, if I add 35 and 127, I get 162.5, and if I take the average, so that comes out to be 81.25. So 81.25 is approximately equal to 80. And also talking about the properties, so these are all halogens. Okay, these are all non-metals. They have a valency of 1. So properties are also same, and we are getting the average almost equal to the mass of the second atom. Okay, I hope that is much clear to you. Now, next is advantages of classification. Next is Newlands Law of octaves. So this Dobonier tried, it was not very successful. Now, why wasn't it very successful? Because he could only find three groups. Okay, he couldn't arrange all the elements which were known at that time, okay, into triads. So there was another scientist who came up with his theory, that is the Newland. Now Newland, what he did was he arranged all the elements which were known at that time in order of their increasing atomic mass. So he found that the property of every eighth element, it is similar to the property of the first element. Okay, now Newland compared this thing to the notes of music. Okay, so what was the thing? See, we are having these notes of music. In English, it is do, re, mi, fa, sol, la, ti. And in Hindi, as you all know, it's sa, re, ga, ma, pa, da, ni, sa. Okay, so you can see the sa is coming again. Okay, there is a kind of repetition. So that is what was told by the Newland. Okay, so according to Newland's law, he told that when we arrange the elements according to their increasing atomic mass, the property of every eighth element starting from any element are a repetition of properties of starting element. Okay, now let's see. Let's say we are starting from lithium. Okay, so 1, 2, 3, 4, 5, 6, 7 and 8. So this is the eighth element starting from lithium. Okay, so he told that the properties of lithium and sodium would be somewhat same. Similarly, if I start from boron, okay, then eighth element would be aluminium, and he told that the properties would be approximately same. Okay, but this option was also not taken into consideration very much, because there were certain shortcomings of this particular law. Now, first of all, he couldn't arrange all the elements in this particular table. Okay, so there were some good things about this, that it was working very well for the lighter elements. For example, lithium, sodium, potassium, they were brought together. Okay. Next is all the properties were related to their atomic masses. But what was the reason we couldn't take it further? First thing, as you can see, that he just gave one place, okay, the place which was reserved for one element, he gave it to two. So how can one seat occupy two elements? That was a problem. He couldn't give the satisfactory answer. Next, it was not working well for the heavier elements. Okay, so till calcium it was okay, but after calcium he was not having a good answer. Okay, why the elements were not being arranged properly. Okay, next thing was the properties of, see, iron and cobalt nickel. Okay, so they were placed apart, having even though having kind of same properties. So there were these some shortcomings, because of which we needed to switch on to some other option. Okay. All right. So then who came? Then Mendeleev came. So what happened in the case of Mendeleev? So in 1869, Dmitry Ivanovich Mendeleev, he was a Russian chemist. He tried to arrange all the 63 elements which were known at that time in increasing order of their atomic mass. Okay, so he tried to arrange all the elements which were known at that particular time in order of increasing atomic mass. Now, elements with similar properties were put in one after the other in same vertical column. So that is known as group. Okay, so the elements which were having same kind of properties, they were put one after another in one vertical column, with, which we call as group, with blank spaces. Very important, with blank spaces where the expected periodicity of properties was disrupted. Okay. Now, that is a very, very, very important thing about Mendeleev's periodic table. So this was a thing that whenever he found that, okay, this property is not very perfectly fitting, so he just left a place blank. Okay, so he just left a place blank to be occupied by some elements in the later time, and that was very much successful, how we will be seeing in a while. Okay, now what happened after that? He observed that elements with similar properties, they occurred at regular intervals, and this thing he defined as periodicity of properties. Now what is periodicity of properties? It is a kind of repetition of certain properties which are occurring after a regular interval. Okay, so if I have to define periodicity, it is the repetition of properties. Okay, after a certain interval. Okay, after a regular or certain interval. Now, on the basis of this, he gave a law which we call as Mendeleev's Periodic Law. Now, what does Mendeleev's Periodic Law states? That physical and chemical properties are a function or a periodic function of their atomic masses. Now, Mendeleev connected the physical and the chemical properties of elements to their atomic masses. Now, these things are very important. These small sentences are very important as per talking about your examinations. Okay, so who related the properties of element to their masses? Who related the properties of the elements to their atomic number? So these are the things which become very important from your examination point of view. Okay, so I hope you understood this thing. So he observed that all the elements, when they are arranged according to their increasing atomic mass, there were certain properties which were repeating, and he called this method, this phenomena, as periodicity of properties. And according to Mendeleev's periodic law, he stated that the physical and chemical properties of any element, they are periodic function of their atomic masses. Now, what is a periodic table? So we all know periodic table is nothing but just a chart of elements which is prepared in a method, in a way that all the elements having similar properties, they are occurring in same vertical column, which is also known as group. Now it is known as periodic. Why periodic? Because all the elements having similar properties, they are occurring at fixed interval or period. And table, of course, because it is arranged in a tabular format. So I hope you might have understood why is it known as periodic table. Now this is first of all the periodic table which was given by Mendeleev. Okay, so as you can see, he just tried to arrange the elements which were known at that time. Okay, now we will be seeing some of the features of Mendeleev's periodic table. Okay, now essential features of Mendeleev's periodic table. First, Mendeleev's periodic table contains vertical columns which are known as groups and horizontal rows which are known as periods. Now there are 8 groups, group 1 to group 8. Each of the group from 1 to 7 is divided into 2 subgroups. Okay, now you can see here, okay, we have periods down, then we have groups. Okay, now we are in total having the 8 groups, and each group, it is divided into 2 parts, which is A and B. Now every group is divided into A and B apart from the 8th one. Why? Because the 8th group, it had got no subgroup. Why? Because the inert gases, they were not known at that time. Okay, right now we are having inert gases or the noble gases in that group, but at that time inert gases were not at all known. Okay, so I hope that thing is clear to you. Okay, then all elements of a subgroup have similar properties and show the same valency, which is equal to group number for up to group 4, or group number subtracted from 8 from group 5th to 7th. Now what does this point explains is, as you can see, that all the elements of a subgroup, they will have similar properties. Okay, see, you can see it here, you can see it here. Okay, so these are the elements which will be possessing same properties. Okay, next thing that was told is that the valency, okay, the valency of the group, it's from group 1 to 4, it is equal to 1, 2, 3 or 4. Okay, and from group 5 to group 8, or group 7, it is equal to what? It is equal to group number subtracted from 8. Okay, so 8 minus 5, 8 minus 6, 8 minus 7, etc. So this is how to calculate the valency of group 5th to 7th, and otherwise from 1 to 4 it is same. Okay, that is 1, 2, 3 or 4. Next, in a period, elements gradually change from metallic to non-metallic character, or metallic character decreases as we move from left to right across a horizontal row. Now, as we move from here to here, what will happen? Metallic character decreases. Okay, so that was what was told by Mendeleev, that as we are moving across a period from left to right, okay, in that horizontal way, what happened? The non-metallic character will increase. Okay, so that is elements, they are changing from metallic to non-metallic. Okay. Now here, what was the thing? Just a minute. Yeah. So this particular table, which you can see on the screen, it was published in a German journal in the 1872. So he used the letter R. You can see here R, right, to represent the element of that particular group. So if I talk about R, so here H, here Li, here Na. So this is R means the element of that particular group. Okay, hydride of any element of group 4 is written as RH4. Okay, so for example CH4, Si4, SiH4. So this is how, so basically R means what? The element of that particular group. Okay, and talking about the oxide, what did he do? He tried to write it this way, like H2O, Na2O. So basically R resembles the elements of the group that we are talking about. Hope that is clear. Now, merits of Mendeleev's periodic table. So what were the good things about Mendeleev's periodic table? What were certain things that were, kind of disadvantages, or we could say demerits or defects? We will be discussing these things. Okay, so I hope you are with me till now. Okay, now grouping of elements. So what was the basic or the greatest advantage? That he just generalized the study. That means he brought all the elements which were known at that time into just 8 groups. Now we didn't have to study about one element. We just have to, we could study about the group, and in which certain elements were there. So it made the study easier. So because of grouping of elements, what happened? The study became easier. Okay, gaps for undiscovered elements. Now that is very amazing, or I can say the perfect thing which happened in Mendeleev's table. So he just didn't, try to push the elements which were present at that time into some category or the other. He made sure that the elements which have same properties, they are in the same column or group. So when some of the elements, they were not following this particular trend, he left the spaces. So that is the thing, okay, which was very amazing. He didn't just push, or he just didn't put all the elements here and there, but he gave a very systematic table wherein if the properties were not following, or if there was no element with certain properties, he left those spaces. So these gaps, they were actually left for the addition of elements which were not known at that time, but he thought that these elements could be discovered later in the time. Okay, now prediction of properties of undiscovered elements. Okay, so not only he left the spaces, but he also predicted the properties of the elements which were known at that time. And how did he predict the properties? He just tried to predict them on the basis of the properties of elements which were lying adjacent to the vacant slot. For example, this is a slot. Okay, here we don't have any element. That means it is empty. So he tried to predict the properties of here, let's say element X, on the basis of the elements which were present here and here. Okay, and more or less he was mostly correct. So let's see what are the properties that he predicted about what. Now he had one, okay, let's go for ECA aluminum. Okay, so ECA aluminum means there was an element which was not known at that time, okay, which had to lie below aluminum. Okay, now talking about gallium which was found. So this was the actual element, and this was what was predicted by Mendeleev. Okay, now talking about the mass. Okay, so mass of ECA aluminum, that is what was predicted by Mendeleev, it was 68, and gallium, its actual mass is 69.7, almost near. Next is density. Density, if I talk about the density that was given by Mendeleev, it was 5 0.9 gram per cubic centimeter. And the density of gallium was found to be 5.91 gram per cc. So see how appropriate it was. Next, if I talk about the valency. So the valency was 3, which was predicted by Mendeleev, and gallium's valency is 3. And he also gave the formula for oxide, which was M2O3. So M is the element, okay, and the oxide formula for gallium is Ga2O3. So you can see how near he was, okay. So that was a great advantage that we got from Mendeleev's periodic table. Okay, now not only this, he also predicted the property of another element, which was germanium. So germanium needed to be lie below silicon, right? So he named it as Eka silicon. Okay, now let's do it here. It was Eka silicon, and the actual one was germanium. Now let's see how much the properties resembled. Okay, so he told that the mass of Eka silicon, that is the element which would take place of this empty space, it would be 72, and the germanium mass, it is 72.6. Talking about density, he told density would be 5.5, and the actual density of germanium, it is 5.36, approximately again near. Next, if I talk about valency, so both of them are having a valency of 4, and the formula of oxide which was given by Mendeleev, it was MO2, and the germanium, the oxide formula is GeO2. Okay, so this is how it resembled. So that was a very, very amazing thing which was in the periodic table of Mendeleev, that he predicted the properties very accurately. Okay, next is incorrect atomic mass corrected. So he was also able to rectify or correct the values of atomic mass of certain elements, like let's say gold and platinum, and he tried to put these elements according to the similarities in their properties. Okay, so because of this, the atomic masses were also corrected. Now we were having such amazing things in Mendeleev's periodic table, so what was the reason that we discarded it? Okay, let us see some of the reasons which were not very good, or which were kind of defect in the periodic table. Now, first is anomalous pairs. So, if I talk about some of the pairs, anomalous pairs, which means the principles or the properties which were given by Mendeleev, some of the elements, they were not following that. Okay, for example, if I say argon, so the argon atomic mass is 39.9. Okay, and potassium, the mass is 39.1. So according to Mendeleev's periodic table, potassium should be put first and argon later because of the increasing atomic mass. But what was the problem? That argon was coming in the first position before potassium. So this was the problem or the defect that he couldn't answer. Next, talking about cobalt. The cobalt had atomic mass of 58.9. Again, it was preceding nickel, having the atomic mass 58.6. So again, this cobalt should come after nickel, right, according to Mendeleev's periodic table, because he told that we're going to arrange according to the increasing atomic mass. So that was the problem. And third problem was between tellurium, having the mass 127.6, and iodine having mass of 126.9. So again, tellurium, it is coming before iodine. So these elements, okay, so these elements should be placed after the below elements, which didn't happen in Mendeleev's periodic table. So this particular thing was falling against his principle. Okay, so first is the anomalous pair. So these were the 3 pairs. Next is the position of isotopes. Now what are isotopes? So isotopes of an element, or any these are the atom of an element having the same properties but mass are different. Okay, so I can write same chemical properties but different masses. Now see students, according to the Mendeleev's periodic table, he told that when we arrange the elements according to their increasing atomic mass, right, this was the sentence which was given by him. If I talk about isotopes, they are again having different masses. So if we stick on to this statement of Mendeleev, what should we do? We should be giving separate position to isotopes, right? Separate position to isotopes. But in the periodic table, we didn't have any separate position for isotopes. So this was again a question that was not answered satisfactorily. Okay, the isotopes, they were not assigned, they were not given any separate places. Okay, next is grouping of chemically dissimilar elements. Now he just grouped some of the elements which were not very similar, talking about their chemical properties. Now if I talk about copper, if I talk about silver, now copper and silver, they are completely different from lithium and sodium, right? Or I can say alkali metals. But what did he do? He put the elements together. Okay, so he just tried to put the copper and silver with lithium and sodium. So I'll just show it to you from the periodic table. See, copper, silver, gold, lithium, sodium, potassium. So they were placed in a same group. Okay, now that was a problem here. Next was okay, so that was the main problem. Next is grouping or separation of chemically similar elements. So as I told you, he tried to group together the elements which were not very chemically similar. He also separated some of the elements which were chemically similar. Okay, now gold and platinum. So they are chemically similar, but they were placed in separate groups. Okay, so again he didn't have any answer to that. Okay, so gold and platinum, they were separated. Okay, I'll just show that again to you. Yeah, you can see here gold and platinum. So they are again separated. Okay, but the properties of both are somewhat similar. So that was again a problem in Mendeleev's periodic table. Next is electron arrangement. So in Mendeleev's periodic table, there were no explanations for electron arrangement of elements. So it gave no explanation of electron arrangements. Now how are electrons arranged in the atom, in the elements, so there was no information about that. And also talking about position of hydrogen, so in Mendeleev's periodic table there was no particular position, okay, given to hydrogen, so it was given no fixed position. So that was again a issue, that was an issue over here. So it was considered in the group 1A, and also it was considered in group 7A. Okay, now why this happened? Because first of all it forms positive ion also, and it forms negative ion also. Okay, so that was the reason why the position of hydrogen was a confusion, and it was not resolved in the Mendeleev's periodic table. Okay, so I hope you understood this particular thing. Let us quickly revise, and then we will be moving on to certain questions. Alright, now we'll be revising from the very start, okay, talking about Daubigny's triads, Newlands Law of octaves, and Mendeleev's periodic table. Okay, so we will be having these three revisions, these three topics revisions, and then we will be moving on to the certain questions. Yes, Saurav, hello. Now the position of hydrogen has changed from the periodic table. Oh, okay. So in the Mendeleev's periodic table, that is what I am telling, that it was not answered properly, that where to keep it. Okay. Now talking about the earlier attempts of classification. So the first attempt of classifying the elements, it was done into two categories, metals and non-metals. Okay, now when the scientists, they tried to arrange them into metals and non-metals, there was again this problem that in a particular category many elements were falling. So this again gave no basic sense of arranging the elements. After that, Daubigny came, okay, and he gave the law of triads. So what did Daubigny do? He arranged the elements into groups of 3, which was known as triad. Okay, so he took the elements and he told that in a triad, let's say there are 3 elements, X, Y, and Z. So he told that they will be having similar properties. Okay, and the atomic mass. Okay, so what did the law of triads say? Said that the average of masses of first and third, that is X and Z, would be equal to mass of Y. Okay, so it was falling well for some of the elements, but that didn't apply for all of the elements. Okay, for example, if I take the case of calcium, strontium, and barium. Okay, so all of them, first of all, they are metals. Okay, they form alkaline oxides, and third is their valency is 2. So yeah, similar properties. Now talking about the mass of calcium, which is 40, and the mass of barium, which is 137. So according to Daubigny triad, the average of this, that is 137 plus 40 upon 2, which is equal to 177 upon 2, which is 88.5. This should be approximately equal to the mass of strontium. So the mass of strontium over here is 88, and it is approximately equal. Okay, so that is what was told by Daubigny triad. Okay, but this particular law couldn't go further because he could only group he could only find 3 groups. Okay, now for example, let's take a case of fluorine, chlorine, and bromine. So these are also the halogen. Okay, these are also having same properties. So according to Daubigny's law, that they should also be following the same thing, that is the average of mass of fluorine and bromine should be equal to the mass of chlorine. So if I take the mass of fluorine, which is 19, and the mass of bromine, which is 80, if I take out the average, which is equal to 49.5. Now, the actual mass of chlorine is 35.5, which is nowhere near to 49.5. So here the Daubonnier's law was discarded. Okay, so that was the issue over here. Next came was Newlands. Okay, so what did Newland try to do? Newland tried to arrange all the elements which were known at that particular time into groups. Okay, so he he connected this thing to musical notes. Okay, now he told that first of all he arranged all the elements according to their increasing atomic mass. Okay, and then what he said that if we are arranging the elements according to their increasing atomic mass, the properties of the 8 elements starting from any element, they will be kind of repetition. Okay, so that was the law which was given by Newland. Okay, now the merits or the good things about his law was it was working well for lighter elements. Okay, like for example lithium, sodium, potassium, they were brought together. Okay, next is it related the properties of elements to their atomic masses, and there was a periodicity seen for the very first time when Newland gave his law. Okay, next is what were the demerits or why were the Newland's law discarded. So it was not working with heavier elements first of all. Next great demerit I would say was he placed 2 elements at one position at single or one position. Okay, and third demerit was elements with similar properties. Some of the elements they were placed far apart. So elements with similar properties were placed apart. So that was again a demerit. So these were the 3 basic demerits because of which Newland's law had to be discarded. Now after that, who came? After that, Mendeleev came. So Mendeleev gave his periodic law. Okay, so the periodic law or the law which was given by Mendeleev, it said that the physical and chemical properties of elements are periodic function of their atomic masses. Okay, so this was given by Mendeleev. Okay, now talking about the periodicity. Now what is meant by periodicity first of all? Periodicity is the repetition of properties of certain properties of the elements at regular intervals. Okay, so that is meant by periodicity. Now the basic or the essential features of the periodic table which was given by Mendeleev. First of all, there were 8 groups. Okay, group 1 to 8. Now each group from group 1 to group 7, they had what? They had subgroups which is A and B. Okay, and group 8 it had no subgroup and inert gases were not known at that time. Okay, now talking about the valency, from group 1 to group 4 the valency was 1 to 4 accordingly, and from group 5 to 7 it was 8 minus the group number. Okay, so this was the valency. And he also told that as we move from left to right, the metallic character, it decreases. Okay, so these were the essential or the main features which were given by Mendeleev. Hope that is very much clear. Next is the merits of the periodic table which was given by Mendeleev. Now merits. First merit was grouping of elements. Now we had a general periodic table, okay, and we didn't have to study about each element, but we now had a group. So only we should be or we could be studying about the group, and our work is much done. Next, he left gaps for undiscovered elements. So that is a very important thing. He just didn't throw all the elements which were known at that time into places, but he gave a systematic study. So if the element, okay, let's say if the element which is to be placed here, it is not, having same properties, so he just left the space blank. So that in future, if we get an element having similar properties, it could be placed here at this position. Next, he not only left the gap, but he also predicted the properties. Prediction of properties. And he corrected the atomic masses. So these were the general merits of the periodic table which was given by Mendeleev. Now why did we not switch on to this? We got to another periodic table. So first of all, let's talk about defects. So there were some of the anomalous pairs. Okay, so anomalous pair means according to Mendeleev's periodic table, he told that we should be arranging it according to their increasing atomic masses. But some pair were there which were disturbing or disrupting his sentence. Next is position of isotopes. So as he told that the elements should be arranged according to their increasing atomic masses. Now isotopes, they were the atoms of the elements having same properties but different mass. So according to this, the isotope should also be given separate position, and that was not given. Next is he just grouped grouping together of chemically different elements. So what did he do? Some of the elements which were not very similar, he grouped together, and vice versa. That is, he grouped separately the elements which were having same chemical properties. Next is he was not able to explain the electron arrangement. Okay, and at the last there was a confusion in position of hydrogen. Okay, so these were the main reasons why the Mendeleev's periodic table was discarded, and then we switched on to the modern periodic table and the modern periodic law. Okay, so I hope the Mendeleev's periodic table is understood to everyone. Now we will be doing some of the questions. Okay, now what property did Mendeleev use to put the elements in order in his first periodic table? So he told that the properties or the physical and chemical properties of the elements are a periodic function of their atomic mass. Okay, so according to Mendeleev's periodic table, the physical and chemical properties of the elements, they were a periodic function of their atomic masses. So the property which was used by him was atomic mass. Mendeleev's periodic law states that if you organize elements by their atomic mass, what will happen? First, chemicals elements will overlap, so nothing like that was said. Elements will not share their properties, again wrong. Physical properties will remain same, no. Chemical properties will occur periodically, yes. Oh, I'm sorry, it's B, C, D. Yeah, so Mendeleev's periodic law, it stated that if we arrange all the elements according to their increasing atomic mass, the properties or the chemical properties, they will be occurring after a fixed interval of time. Next, what was Mendeleev's greatest contribution to the history of the periodic table that proved his periodic law to be correct? So, first of all, he arranged all the elements by their atomic number. No. He realized that there was a pattern of reactivity which repeated every 8 elements. So, this was given by Newlands, not Mendeleev. He predicted the existence and properties of new elements. Okay, yeah, that is correct. He identified the law of triads which became the group. So this was given by not Mendeleev but Dobrinier. Okay, now the correct answer was his greatest contribution, of course, it is he predicted the existence of and properties of new elements. Okay. Next, at the time of Mendeleev, the number of elements which were known, it was 63. And the last question is, the properties of Eka aluminium predicted by Mendeleev are same as properties of later discovered elements. So he told the position, the properties of the element which was discovered later. Okay, so talking about Eka aluminium, he told that these will be the properties. Atomic mass would be somewhat 68. Then talking about density, it would be somewhere near to 5.9 gram per cubic centimeter. Then it was the valency, which was given as 3, and oxide formula, it was given as M2O3. Now we had an element which was discovered much later, which is none other than gallium. So gallium had similar properties, like the mass was 69.7, the density was 5.91, then valency of course was 3, and the formula of oxide was Ga2O3. Okay, so this was the correct answer over here. Okay, I hope this is clear to you. Okay, now students, a very important information for all the students. First of all, Unacademy subscription features. So if I talk about Unacademy and subscription, the main reason is, first of all, you are going to have your term 2 examinations very soon now, right? So your examinations are very near, and it's high time, students, that you gear up your preparations, you start your preparation, you start your revision, especially now. Okay, now Unacademy provides the Plus subscribers very amazing features, which are, you can learn from comfort of your home. You will be having unlimited access to all the courses which are provided here at Unacademy. Then you will be taught by the top educators of India at one platform, which makes your work much easier. Apart from this, you will be having doubt clearing sessions. So in our courses, we will be having certain doubt clearing sessions which would be completely dedicated on all the doubts which are taken from students, and also answer writing sessions. Now, what is answer writing session? It is basically how do you manage the time of 3 hours and write the answers effectively. Then we have exhaustive coverage of syllabus, that is your syllabus would be covered, okay, and you will be having revision sessions also. Then you will have mentorship and guidance of all your faculty. You will be getting all the study material in the PDF format so that you can refer it whenever you want. We will also be having practice tests. So here tests are very important, as you know, to know how much we are learning, how much we are able to understand. So we are having practice tests. We do have practice test series, okay, and also the batch courses. So students, you can use my code, which is RITIKACLIBE. So this code you can use, okay. You will be getting daily practice session, weekly mock test series. You will be getting live quizzes, daily MCQ, and batch courses. So these are the important things that you will be getting. Now talking about how to subscribe for Unacademy Plus. Okay, so you can see or you can select the timing as per your requirements. Okay, you can go for 6 month, 12 month, 24 month, 48 month, whatever you are comfortable with. And here you can use my code, which is RITIKA CLIVE. So please use my code, okay, to get the 10% discount. Now, a very important information for all the students of grade 9. See, students, the time is near. Okay, your examinations are very soon going to start. So Unacademy is starting the new batches, the crash course batches, okay, for all the grades 9 to 12. Now for grade 9, this batch Mavericks, it's all subject batch with delivery in English language, okay. Here physics will be taken by Kalyan Krishna sir, chemistry will be taken by Manisha ma'am, and biology will be taken by Vani ma'am. So you can see the timings of these classes, and it is going to start from 17th of January 2022. Now if you subscribe for grade 9, okay, you will be getting the subscription of grade 10 to 12 for ICSE absolutely free. So this is an amazing opportunity, students. Please don't fail to avail it. Similarly, the Hindi delivery batch is Udan, okay, and again it will be started from 17th of January. Math by Shivam sir, physics by Vibha ma'am, biology by Lakshya sir, and chemistry by Bhavna ma'am. Now, next talking about the Unacademy free special classes. So students, the Unacademy has the special classes every day, which are absolutely free of cost, okay. And here some of the features that are very amazing are real-time interaction with your teachers. You can use chats and emojis. You can have poll and leaderboards. You can compete with your friends, of course. You can also ask questions using question tab. Now the question comes, how to watch the special class? So nothing special. You need to download the Unacademy Learner app, okay, and just open the app and click on Get Started. Enter your mobile number, your OTP, okay, just enter the OTP. Then sign up using the mail ID, okay. Now after that, you will be selecting your goal. That is, in your case, it will be grade 6 to 12. Select your class, the boards, that is CBSE, State Board, or ICSE Board, and your language, preferred language, Hindi, English, whatever. Now students, in the description of this video, you will be having a special class link. If you click on it, it will be showing a pop-up notify me. So please click on notify me, and you will be notified 10 minutes before the class is going to begin. And of course, you can use my code to unlock the special class free of cost. And you know, my code is RITIKACLIVE. So please use this code here, okay, to unlock the class. Okay, so let's recap what we studied today. We basically studied about Mendeleevs Periodic Table. What was the Mendeleevs Periodic Law? Okay, then we learned about some of the special features of Mendeleevs Periodic Table. We went on to the merits, that is the advantages or the good things about Mendeleevs Periodic Table, and why was it discarded, that is what were the defects in the Mendeleevs Periodic Table. Also, we solved some of the questions pertaining to Mendeleevs Periodic Table. So I hope that you might have understood everything. Okay, we will be meeting in the next class, in which we will be learning more about the periodic table. Also, we have done various sessions on periodic table, that is the Dobonius triads, Newlands Law of octaves. So if you have missed on to any session, you can go to the channel of Unacademy and you can see the videos listed there. And also, please don't forget to download the app of Unacademy and try all the features absolutely free of cost. So all the best for your exams. Let's meet in the next session. Thank you, everyone.